Thank you very much. Dear ladies and gentlemen, it's really a pleasure to be here, to visit your lovely country, to meet all the friendly people of Japan, and not at least to be invited to present at the Suruga International Symposium. This to give a presentation on one of my favorite topics, and that's about how to convert a liability to an asset, to the benefit for the society, for the environment, but also for the industry, to prove that the nuclear industry is sustainable. I had problems with the Japanese signs, but now I have. So the agenda for the presentation is to start with to make a brief introduction of Cyclife Sweden, provide some strategic perspectives on management and treatment of retired large components from the nuclear industry, give an overview of the handling and treatment process, to share some case studies with you, some reference projects, to provide an outlook both in terms of treatment but also into facilities, and finally conclude my presentation. If we start with Cyclife Sweden, Cyclife Sweden is a company which was founded in 2016 when we were purchased by EDF of France. Previously we were part of the Studsvik Group. If we have a look at the site, which also has the name Studsvik, and Studsvik means the cattle bay, so it's where you have the cattle along the Baltic Sea. The site was developed in the late 1950s, and it was formerly a state-owned research facility. There have been several prototype and material test reactors operated on the site. The last one operated until 2005. Up to the 1960s, Sweden had its own reactor program or own reactor design, but later it was converted to the BWRs and PWRs. This site is really a key asset for the Swedish nuclear industry. Currently, there are 3 nuclear license holders. It's Cyclife Sweden working with the back end, Studsvik Nuclear, who is working with the operational parts regarding fuel and material testing, and then we have a legacy part cleaning up after the research period. If we have a look on the site from the other side, we can see that the site is located just by the coast, by the Baltic Sea, which is very, very important for us, since our company are welcoming large components to the site, and most of the large components have to be transported on water, and it's just a few hundred meters from the pier up to the treatment facilities. If we have a look of the experiences of our company, we have an incineration facility which was started up in 1976. And the first international treatment campaign took place in 1983. And the facility has been modernized and enhanced over the years and is still operating and will be operating. We also have the metal treatment facility, which was started up in 1987. And just the year after, we had the first international treatment campaign. Today, this facility is providing treatment services to 14 European countries. And our ambition is also to get contracts overseas to support other countries to convert liabilities to assets. The reason for the successful operations is the close dialogue with the material waste owner. Since there are so many local conditions, restrictions, and preferences that has to be considered already from day one in the planning and throughout the entire campaign. Since Sweden has the condition that residues containing the radioactivity will have to be sent back to the country of origin. A key part of the setup is that there is a residual waste guarantee. It is mandatory. It has to be signed by the waste owner, but also countersigned by the regulatory body prior to shipment to secure that the residues can be shipped back to close the circle. If we look at the operational principles of the facility, we are very, very strict on that only waste and metals conforming to the waste acceptance criteria, general or product specific, are accepted. So we should have no orphan waste in the facility. There is also a treatability review performed prior to transport, because safety is always number one. We need to be fully convinced that we can make a successful treatment of the material. Since we are serving different countries, the operations are performed in isolated campaigns. That is to prevent cross-contamination, because it could be a problem. For example, if British nuclides are mixed with German nuclides and should be sent to Germany. So we are always working in isolated campaign to make sure that the radioactivity is sent back to the country of origin. We have 3 years from the date of temporary import for treatment until the residues have to leave the country. And this is according to the specific permit, but also according to the European directive. And this is really mandatory. The residues will be managed either for intermediate or final conditioning as per customer requirements. So we can do grouting, super compaction, or whatever to fit into the disposal program in the country of origin. The metals are treated for clearance. As a part of the concept is an ownership change when the clearance criteria has been fulfilled. And then that we're doing the recycling of the material in the closed neighborhood, and that is recycling from the manufacturing into new products. Having a look at some strategic aspects, this is really, really important. It's about capabilities to do services, to have robust systems, proven concepts, to secure capacity so that what you take on can be delivered, to secure that there is a sufficient legal framework, that we can have predictable results, and not at least that we will bring all the stakeholders on board to make them feel confident and that we are a trusted actor on the market. One important part of this is to establish a treatment concept. What you see on the screen here is what is done for large component. So it starts already at the power plant, and then there is a set up for how to transport the material, how to take it apart, how to do the decontamination to reduce the activity, how to do the melting aiming for clearance, how to check the ingots from the melting prior to clearance and recycling, and not at least how to manage the residual waste to make it fit into the concept in the country of origin. One really, really important part of this, when we're talking about metal treatment is to have a robust metal recycling concept that is understandable by all the parties, the regulatory body, the buyers of the material, the future users of the material, as well as the other stakeholders. So what you see on the screen is the Safe Life metal recycling concept. We import materials to our site for processing. In this process, there is a secondary waste generated, which is returned to the owner of the material shipped to the facility. The cleared ingots are then, upon completion of the clearance process, they are sent out to the industry, to the metal industry, for the manufacturing of new projects. Depending on the properties of the ingots, it could be that it will be prescribed that it should be melted together with other material to form the new product. But this setup, it's proven that both the new products as well as the residues from the external treatment will have a radioactivity content below the general clearance levels. So there is no radiological problem anywhere in the process. And this is really, really important to build the trust, not at least from the metal industry, because they are very scared about radioactivity. We need to bring them on board. Another important part is to build a legal framework. And this is examples of what we have for our Swedish facilities. There are laws and regulations that fit into the needs of the nuclear industry, but also set the rules for the nuclear industry. We need to adopt to European directives and as well as international directives when it comes to transport. For the operations, there will be specific permits who set the rights to operate the facilities, to set the rules for import for treatment, import of waste for treatment, set the rules how to re-export the residual waste, rules for interim storage of the material, not at least the license for clearance of the ingots from the melting for recycling out in the conventional industry, as well as the environmental conditions for the treatment facilities. As understood, we are working with international shipment of materials for treatment. And that is something that you will have to demonstrate. Why is it important to ship large components from country to country, etc.? What is the added value? And based upon the experience we have, it is an established and recognized good practice, both by our customers' regulatory bodies, as well as the international agencies. By this treatment, we provide a significant volume reduction for combustibles from incineration. For the metals, it achieves a high recycling rate, which result in significantly less waste for disposal as radioactive waste, and in a form that is suitable for the final repositories. But this is not the entire solution. And this is important in this symposium, that the external treatment is a complement to the local activities on site. All materials should not be shipped somewhere else. It should be local treatment, local clearance, local initiative, combined with external treatment for certain materials. That is our experience and advice. As said earlier, that shipments to our facility, they are for large components by ships, but it could also be by road. As shown on the previous slides, we have a harbor for seagoing vessels. We can receive components up to 30 meters long and with a tonnage of 400 tons. All transport must respect the transport regulations that is prescribed, and as said earlier, it also has to meet our waste acceptance criteria, either the general criteria or project specific. On the right side, you see examples of components. The upper one is transport from Spain to Sweden for treatment on road, and the lower on the right side is a turbine rotor from a German nuclear power plant to the Safe Life facility for treatment. I will say a few words about the handling and treatment process. And in this case, I will make a zoom in on the steam generators from pressure water reactors. A lot of the activities are similar for other types of components, but the steam generators are a little bit special since it's a complex design, which to a large extent are free from radioactivity or close to free from radioactivity, the secondary side, while there are certain parts in the components which are heavily contaminated. And it's challenging to keep those parts apart to secure clearance of a big part of the material. Firstly, I will give an historical overview of the steam generators. It has been a journey for us. In 2005, the first steam generator was shipped to our facility for treatment. It was a common research and development project together with the Swedish utility, see how to do the steam generator treatment in an efficient way. Based upon the findings from this first treatment campaign, a second generation of treatment concept was established. It has been applied on 12 steam generators with a good success. But also after the second generation, we are seeing that there are potential improvements to make it even better, which means that upon the acquisition of our company by EDF, a program was started to build the third generation of treatment concept, since there is such a large amount of similar components throughout the world. And this third generation will be applied on at least 22 steam generators, likely much more. Having a look at the preparations, as said in some other presentations, the radiological characterization is key. Also to have the licensing in place quite early is important. And in a practical view, to arrange the evacuation from the containment. Looking at the shipment, the transport is key. We have experience on receiving steam generators both loaded on deck on vessels, as well as below deck shipments in ro-ro vessels. And when the components have been unloaded from the ship, we are using transport with the multi-wheel carrier from the harbor up to the facility. And this has been done for, I would say, hundreds of components, so there's a big experience in this. When it comes to the facility, it's mandatory to make an arrival inspection to make sure that everything is as it has been declared. The components are placed in a buffer storage, and at a certain date it's time for processing, and then the facilities are moved from the buffer storage and entering into the facility. For steam generator, the first activity then is to separate the steam dome, which should be very low contaminated, if contaminated at all, from the rest of the steam generator. the steam dome is segmented, and depending on the conditions and the regulatory approval, the steam dome could either be melted, aiming for clearance, or just cut in pieces, decontaminated, and cleared as material. The next activity is to separate the water chamber, and then we are on the primary side with a lot of activity to separate that from the tubular part. The water chamber, or the water box, which is really contaminated, is then decontaminated. And since our experience is that grit blasting or similar is not good enough, we are applying milling to remove the surfaces of the components. When that is done, we are cutting the tube ends of the steam generator, because all the tubes are as U-bends. And then we are removing the tubes with a special machine, because the tubes contains a lot of activity and a high dose rate. So it's important that this has to be done remotely. Then the tube plate is separated. The tube plate is pre-treated and made ready for melting. And then finally the secondary side shell is separated and cut in pieces for melting. And if we have a look at what this means, if we look at the mass balance for steam generators, up to 80% of the material can be recycled, which is quite a lot. Other type of components, we could be as high as 95, 98%. It depends on the properties of the components. The volume reduction is significant. More than 90% of the volume will be gone thanks to the clearance and recycling. The residues, it is mainly the tube material, which is compacted and cut into small pieces. It's in the order of 70–80% of the total residual waste. We have slag from the thermal cutting, and we have slag from melting, and of course some other fractions. But those are the main three ones. Let's have a quick look at case studies. Steam generators from Sweden. We have treated in total 9 steam generators from the power plant Ringhals, each about 300 tons. We have had a recycling rate of in the order of 70% of the delivered tonnage, and the volume reduction exceeding a factor 10. So that means that 1 cubic meter in is less than 1 cubic meter out as residual waste. So overall, a very big success and a pleased customer. Moving to BWRs, boiling water reactors. This is a case study for the power upgrade of the Ringhals, or the Forsmark nuclear power plant. And it was mainly the turbine island components, in total 1,320 tons. We had a 95% mass recycling rate. All the residues were characterized and packed for disposal in the Swedish repository, and the volume reduction factor exceeded a factor 20. And finally, among the case studies, which is, I would say, that is my favorite, and that is the Berkeley boilers from the UK. In total, 15 boilers were shipped for treatment. And then somebody say, how could it be 15? It should be 16. And it was 16 from the beginning, because it's the first boiler, there was a project to make in situ decommissioning of the boiler, which failed massively, which resulted in the decision to ship them for treatment. And this project, there is a lot of papers written from conferences, etc., is very interesting, especially when it comes to stakeholder management. because here the people from the NDA and the Magnox together with our people, they went to pubs in the neighborhood to speak to people where the transport should pass through during this transport exercise, etc. So established trust and good relation, and it became a success story. There was a lot of people along the road. The kids were free from school to visit the transport, so it was a very good happening. We did size reduction, and we were able to recycle 94% of the tonnage, which is really, really good. And we had a volume reduction factor of exceeding 75. So 75 cubic meters in, less than 1 cubic meter in return as secondary waste. Having an outlook on the treatment, as said earlier, our company currently have 22 steam generators contracted for treatment, and significant amounts of other large components and metal scrap. Because as we all know, there is a big decommissioning campaign in Europe, but also outside Europe. A lot of the deliveries have started. For example, we can see the upper part from the Fessenheim steam generators on the picture. And common for all the coming projects are the customer expectations. They would like to see robust and smooth processing, of course a large volume reduction, safe recycling, and that the residues generated, that they fit into the system in the country of origin. Having an outlook on the facility development, Cyclife is currently investing a lot in a significant extension of the treatment capacity. The reason is that we see that the current capacity is far from enough. In Sweden, we are building a second production line, which is illustrated on the upper picture here. It will double the capacity of the metal treatment. There is a new production unit to be built in France called Technocenter, which is to be built at the Fessenheim site, partly to demonstrate this responsibility for the region. It will be a big asset for France, but for the entire Europe as well. And currently there is a new disassembly and segmentation facility built in the UK, which has alpha waste capabilities. And we are also at the same time working hard together with the metal industry to perform clearance for safe recycling, aiming for a joint strive towards a circular approach. Some conclusions. As we see it, rip and ship of large components is an established and robust disposition route. It works very, very well. But we are not serving just the decommissioning market. There is also replacement of components during operation, and we will see a lot more of that now the coming years, thanks to the lifetime extensions of plants, etc. So it's a shortage of the outage time, and in the decommissioning, it will shorten the decommissioning schedule. So we believe that is beneficial for the industry, both in operation and decommissioning. And we are pleased to be considered as an international good practice in management. It's not just about Cyclife, but also for similar facilities. It's also good that it aligns with the waste hierarchy and the strive towards a circular approach, because it will demonstrate the sustainability of nuclear. Not entirely this, but it's an important piece of the puzzle. And it will reduce the volume of waste for disposal. With at least a factor 10. Before, disposal was not a problem, but now when we are talking about building new reactors and to extend lifetime, there will be a significant shortage of disposal volume. So any reduction is good. And we as a company, we also see that this shortage of the treatment capacity, why we are doing investments for the future. Thank you very much.
Thank you very much. So one question from audience. So your decontamination method seems to be the cutting and melting or highly contaminated parts of the equipment. Do you also use the method using high pressure water or acid or some chemicals or slag melting? The other method, do you have?
Yeah, I would say that the main method applied is mechanical decontamination using grit blasting or machining. High water jetting is applied as well. And the chemical solutions as presented by Jerome here before is also applied. So we're having a big toolbox, but the big majority is mechanical decontamination.
And I have just one question. Can you go back to page 10? When you process the waste and separate the waste and the raw materials, in the Japanese usual industry, gives a certificate or report to the original generators. So in your case, you have to send a report to the origin manufacturer. Not really. What we are doing, which is standard, is that when we are doing the clearance of the material, there is always a report back to the owner that the clearance process has been completed. And then the material is either sent without conditions or with conditions to the metal treatment industry. But the receiver of the metal within the conventional industry is also getting a certificate that this material has been checked for reactivity, it meets the criteria, and it's signed off by Saik Life. So it's a quality assurance is very, very important, as well as trust. Okay, so there is no intervention from the regulatory body of the original country. Some
countries they request to have a report back when the material has been remelted. So to close the books, so to say. So in that perspective, but there is no requirements on in which industry or so. That is a task for Saik Life.
Okay, thank you. Okay, so we almost overran 5 minutes, so I would like to close this session.